We are told the radius of the cylinder is 12 centimeters and the radius of the sphere is 3 centimeters. And the sphere is removed from the cylinder and the level of the water decreases by h. So in here, what I've done is I've just drawn half of that sphere, hemisphere, because it is only the bottom half which is submerged in the water. This diagram right here, all I have done is I have just removed that empty part of that cylinder to leave simply the water and the submerged hemisphere. Now we can think of the volume of this thing as being composed of two things, the volume of that hemisphere and the volume of the water itself. Well, the volume of the hemisphere I have remolded into a cylinder, this cylinder right here. This is now the hemisphere just remolded into that shape. And of course, if I were to take away that hemisphere, the water would assume, since it's in a cylinder, would assume this shape right here. Therefore, this thing right here is composed of the volume of the hemisphere, which is here, and the volume of the water. And of course, if I were to remove the hemisphere, it would go down, the level of the water would go down by the height of that now hemisphere, which is this shape right here. So what is the volume of that hemisphere? Well, the volume of the hemisphere is going to be 1/2 the volume of the sphere, and when you pop that through your calculator, you find that you get 18 pi. Just border this off. And the volume of that hemisphere has been remolded into the shape of this little cylinder here. And I want to find the height of that little cylinder. Okay, well, the volume of that cylinder is going to be pi r squared h, and we know that h is going to be 12, because it's now assumed the shape of the larger cylinder, so the radius of this is 12. Popping that through my calculator, the pi's will cancel. H will equal 18 over 12 squared, and that indeed gives me 0.125 centimeters. So, done.